Hello Year 11s, welcome to our next lesson, 14N, okay, so general solutions of the trig equations, okay, so we're going to find a couple of formulas that will be very helpful to find all of our x-intercepts, okay. So what we've got is three formulas, one for each sine, cos and tan, okay, so the first one, where a is an element of -1 to 1, the general solution of the equation of cos x equals a. So remember when we're talking about a, we're talking about the values that we generate from our little handout that we were given with all the exact values. Okay, so examples of a could be a half, okay, square root 3 on 2. So those values that we're generating from the sine or cos, okay, either the horizontal distance or the vertical distance, okay, or if we're talking about the tan function, the gradient as well. Okay, so the first one is cos, okay, so we get x is equal to 2n pi plus or minus inverse cos of a, okay, so that's our first solution that we can get. We've got a few examples moving ahead, okay, so they're going to make a bit more sense. The next one is tan, okay, so to find any x-intercepts of tan, it's n pi plus inverse tan of a, and then the last one is x is equal to 2n pi plus sine, inverse sine of a, or you can use this one, 2n plus 1 pi, all in brackets pi, minus inverse sine of a. Okay, so both of them will work. They're identical, okay, depending on what values you're trying to find. Okay, so we've got a couple of questions here, okay, so find the general solution of each of the following equations. The first one is cos x equals 0.5, okay, so because we're using cos, I'm going to use the general solution for the cos. Okay, and I'm going to state that again. So x equals 2n pi plus or minus inverse cos of 0.5. Okay, remember that 0.5 is our a. Okay, what I'm going to do is I can simplify this. I can find the solution for this. So this is 2n pi plus or minus inverse cos of 0.5 is actually pi on 3. Okay, to get all this under the one umbrella, okay, because there's we can bring it all under 6 in our denominator, and in both of them we have pi, okay, so we have pi, so that pi is a common factor. What I'm left with on the inside is actually 6n plus or minus 1 pi, okay, that is over, not 6, that is over 3, my apologies, okay. And that's our general solution, okay, so I've got a couple of examples later on where we can actually apply this, okay, but to actually find our general solution, that's what we're doing. Okay, the next one is our, for question B, is our tan, okay, so our tan rule is, okay, so first of all, what I need to do is I need to rearrange this first, okay, so I'm going to go tan 3x, okay, equals 1 over square root 3, okay, so that's a function that I wanted. That's the format that I want it to be in, okay. What I'm going to do is to find the general solution, okay. So see how in part A, okay, the value of x at the front was 1, okay, and that relates to the 1 there. Because we've got a 3, we've got some. Remember, we've got some horizontal dilation, okay, so that's going to take effect as well. So how can we input that? What we actually do is instead of writing x equals, we write 3x equals, okay. We write 3x equals the general solution for the tan function, which is n pi plus inverse tan, okay, of our value of a. Our value of a is actually 1 on square root 3. Okay, so that's our solution there. What I'm going to do is I'm going to simplify that first before I bring the 3 to the right hand side. So this becomes n pi plus inverse tan of 1 over root 3 is actually pi on 6. Okay, and that is still equal to 3x. Okay, so what I'm going to do is I'm going to get both of these over the same denominator, so that becomes 6n plus 1. I'm taking out a common factor of both of them, which is pi, and that is going to be divided by 6. Okay, and that's equal to 3x. Okay, now I bring the x across, the 3 across to leave it as the x. So this becomes 6n plus 1 pi, all divided by 18. Okay, or 6 times 3 in the denominator. Okay, and that's our general solution. Okay, just to generate that, it takes a little bit of practice. Okay, just remember with this here, okay, so that step over there, I've actually gone, I've gone 6n pi over 6 plus pi on 6. Okay, so then I've just taken the pi is a common factor up the top, and 6 is a common denominator, okay, and that's how we can generate that solution there. So we need a little bit of practice with our fractions, hopefully not too bad. Okay, and the last one we're going to use the sine one as well. What we need to do is I need to get rid of that 2 first, okay, so what I'm going to do is I'm going to get rid of that 2, so sine x is equal to square root 2 on 2. Okay, we should know by now that square root 2 on 2, remember, we're a bit weird in maths, so we don't like having our square roots in the numerator. We want it in the denominator, and that actually changes to 1 over square root 2. Okay, to find our general solution, okay, we're going to use the formula on the previous slide. So x equals 2n pi plus inverse sine of 1 on square root 2. Okay, so what we do is we find inverse sine of 1 on root 2. Okay, so this becomes 2n pi plus pi on 4. Okay, so it's pi on 4 with that. So what I'm going to do is I'm going to bring them over the same denominator of 4. Okay, so that becomes, I'm going to multiply that 2 by 4, so that becomes 8n plus 1. And I'm going to take pi as a common factor out. Okay, so that's our general solution there in its most simplified version. Okay, so we've used our cos, we've used our tan, we've used our sine. So they're reasonably not too bad how to generate. What we're going to do in the next slide, we're actually going to apply and find what do they actually mean, how can we use them. Okay, so this next one, I'm going to swing my head right down to the bottom now. So it says find the first 3 positive solutions for square root 3 tan 3 of x equals 1. Okay, so this is actually part B in the previous slide. Okay, that was our tan function that we used before. So our general solution for that one was x is equal to 6n plus 1 pi all divided by 18. Okay, so that was the formula that we generated with this function. So I've used a very similar topic. Okay, so what we're going to do is we're going to find our first 3 positive solutions. Okay, so what I'm going to do is, first of all, I'm going to let n equal 0. So that value of n, okay, so I'm just going to start at 0 and try and find my first value. Okay, what I do is underneath, so this becomes x equals 6 times 0 plus 1, close bracket pi, all divided by 18. Okay, so the first value is 6 times 0 is 0 plus 1 pi, so that becomes pi over 18. And that's my first solution. Okay, so that'll be my first x-intercept. The next one, I'm going to go let n equal 1. Okay, so I'm just going to increase that n. Okay, so I've got my first positive solution. I'm going to find my second. Okay, so this becomes x equals 6 times 1 plus 1 pi all over 18. Okay, so 6 times 1, 6 plus 1 is 7, so this becomes 7 pi on 18. Okay, and over here, I'm going to go let n equal 2. Okay, so x equals 6 times 2 plus 1 pi over 18. Okay, so what you'll notice is there's a pattern. So 6 pi on 2 is 12, plus 1 is 13, so it becomes 13 pi on 18. Okay, so it's pretty easy. Once you can find your first value, what you notice is as we're increasing one, we're simply just adding 6 to the numerator. Okay, so because that's a 1 pi over 18, then that becomes 7 pi over 18, 13 pi. If you keep on adding 6, you can get the pattern. I know the next one will be 19, that'll be 25, 31, 37, so on. Okay, if we wanted to generate those values. Okay, so to get a graphical representation of what it looks like, okay, so what I've done is that function that I've brought up here, so I've inputted tan of 3x into my graphing tool, into my graphing table, and then I've entered 1 over square root 3. So what we've actually found is where these lines overlap, okay, and that's what we actually found. So that whole width of the window is 3.14 of pi, okay, and what you find is all those 3 values sit in there. So that first value right there is pi pi over 18. Okay, so it's 1/18 of that whole direction. This next one is 7 pi over 18, so it's just below halfway. Okay, so 7 pi over 18, and the last one is 13 pi over 18. Those are the solutions that we've found. Okay. Okay, so hopefully those examples hold you in good stead moving forward. Okay, again, get some practice. If you need to re-watch this video, again, it is on YouTube. Okay, so I might give you a few little hints and nudges in the right direction. Okay, if you have any problems, please feel free to email me and I'll get back to you as soon as possible. Thank you for listening.